Does this look kind of weird? How do we want it to look? Just like that. And hopefully A is 1, right? Because if it is, we call that factoring by inspection. Like someone was asking me, well, how come sometimes we multiply by A and other times we don't? Well, we still do. If A is 1, though, anything times 1, we just look at the number there, right? Okay? But, so what's the difference? Well, this is f of x. It's not just x squared. It's something bigger, okay? So we start kind of easy. All right, again, we call this decomposition. If A is not 1, like if it's 24, I mean, you try that by inspection, you might be there all day, okay? What's inspection? I throw down a couple sets of brackets. See if I can piece it together. Do I have a simple one here? Yeah, okay. Hey, we had a whole weekend, so let's maybe do that. Okay, factor. Grade 10 question. You should know how to do that. What multiplies to -6 times 1 and adds to 1? What two numbers? 3, 2, yeah, but what's our signs? It's got to add to positive 1, so the bigger one has to be positive. 3 and -2, right? So here we just throw in the numbers. What times what gives you x squared? X times x. We don't have to split this up because you can just do it by inspection. It's not that bad. But do you want to split it up? You can. Okay? You can take those two numbers and go, all right, I want to split plus x up into plus 3x minus 2x. I still have -6. This is called factor by grouping. That's how we do this decomposition thing. What can I take out of the first two? Just x. Okay? What can I take out of these? A 2. But let's make it a -2. That's the only way I'm going to get an x plus 3 in those brackets again. Okay? But check it. X squared, yep. 3x, yep. -2x, yep. -6, yep. And then what's common in both of those, right? And I get the same thing. Okay, we don't have to do this grouping step if that's a 1. We call that inspection. But I know last year, some kids get screwed up. Well, there's too many ways to do these. Well, then you do it like that every time. Okay, you can. It's just not necessary to do all this extra work when we just see what the numbers are. Okay, so all says, blah, blah, f of x is a monomial. We like it to be x squared, but it's not always going to be. This one, I don't think, I've been hearing it all day, I don't know. Someone's got gas. A is 1. When I say A, I mean the coefficient of x squared. I know that's confusing because there was an A there. All right, so we maybe can do this by inspection. What times what is a to the 4th power? What's the square root of a to the 4? A squared times a squared is a to the 4th. We see what that is. So there's no point to substitute here. The bigger ugly ones in about 10 minutes, we will want to substitute something, okay? What two numbers multiply to -14 times 1, if you like, and add to -5? Well, you only got two choices here, right? 14, it's either 14 times 1 or 7 times 2. Must be 7 and 2. Those kind of make a difference at 5. But check it before you go on. I need to have a -5. Put the minus on the bigger one. Do those multiply to -14? Yes. Do they add to -5? Yes. Those are your two numbers. Oop, +2. Okay. But what do we want to do before we go on to the next question? FOIL it. A squared times a squared, check. Okay, 2a squared minus 7a squared is -5a squared, check. Negative 7 times 2, negative 14, check. Okay? So that one's not too bad. A is still 1. Let's try this by inspection. What times what is x to the 6th power? These have to be the same, remember? Here's your clue. What's this term? X cubed. Okay? X cubed times x cubed is x to the 6th. What two numbers multiply to 14 and add to negative 9? Looks like a 7 and a 2 again, doesn't it? Okay? But I need negative, right? So that's got to be minus minus. Those multiply to positive 14, add to minus 9, and Bob's your uncle. Okay? But check it, foil it, before you go on to the next one. Okay? What they're going to say is, like, let's let a substitution be something. Do we really want to substitute in here? This is pretty clear to see, is it not? Do I want to go a is x cubed, and then I can write this as a squared minus 9a plus 14? I think that's more confusing than what it's worth, right? Do we all agree? But you can. If you don't like seeing x to the 6, right, you make a substitution. If I put x cubed in here, I get x cubed squared, which is x to the 6, minus 9 x cubed plus 14. And then it's just like our x squared minus 9x plus 14. We factor it just like we did before. But then when we're done, okay, it'll be minus 7, it'll be minus 2. We have to substitute back in and go, well, that's actually not x, it's x cubed. Okay, is that confusing? Yeah, so don't worry about substitution here, I don't think. But like I said, it's there. If you want to do it, fine. Here, we're going to do both methods, okay? Method 1. We're going to substitute, okay? I don't want to see y to the 4. I would just want to see a squared. So let's let a be y squared. So if we write that out like that, okay, this will still work. This is 4 times y squared, that's y4, okay? Minus 11y squared, there it is, minus 3. This is the same as this, but wherever there's a y squared, I'm going to put in an a. So I don't have 4y squared squared, I have 4a squared minus 11, this is a, minus 3. Good question. With an x to the 4, this is my point. You probably don't want to do this, okay? Just hang on until we get here. I'm just going to show you it'll work, okay? And a, that's little a, the coefficient, is not 1. So here we want to do decomposition. What multiplies to negative 12 and adds to minus 11? How could it add to a less number? That seems weird. All right. Yeah. Okay, but check it. Check it, right? I see people make a mistake here and they do all this work and it's wrong because this little simple thing they didn't check. Do those multiply to negative 12? Check. Do they add to minus 11? Yes. So I'm going to split this up, minus 11a into minus 12a plus 1a, still have minus 3, still have 4a squared.
Wait, where'd your a squared go?
What a squared?
Oh, your 4. Oh,
Right here. Yeah, still there.
you wrote it a little weird.
Okay, what can I factor out of the first two? 4a. What do I have left? A minus 3. Guess what I want out of the second sets of brackets? A minus 3. Okay, that's factoring by grouping. Every time you do decompression, was it what someone called it last time? Decomposition, we're going to get grouping, right? Okay, what can I take out of these two? A minus 3. What do I have left? 4a plus 1. Carmen. Shush it. Okay, but so it's factored, but I can't leave it like that. What's a? Y squared. So I have y squared minus 3 times 4y squared plus 1. Okay?
So, can you show us the other way?
Yeah, that's method 2. I'm going to do that next, as promised. Okay? Like I said, it's probably more hassle and confusing than what it's worth. Okay? So, again, I already did this. I split this up, right? They're already doing this for us. Minus 12 plus 1. The only difference is we got y squareds, okay, instead of our good old y, or here, a good old a. What can I factor out of the first two? 4, just y? Squared, yeah. Okay, so I have a y squared left minus 4 to 12. I need a 3 here. Already have my y squared. Okay, what do I want in my second sets of brackets? Carmen, come and sit here, please. Yes, you were. Thank you. Okay. What do I factor out of here? Doesn't look like anything. So take a 1 out. Sure. Okay. So factor by grouping, take out a y squared minus 3 out of both things. So what do I have left? And is it the same? Yeah, and it better be, right? Okay. Again, check it before you go on to the next question. You FOIL this, it better be the same. Yeah, is this, I think, less confusing? Do we agree? Yeah. Yeah, okay. So when you get y to the 4, or maybe a 6th power, maybe an 8th power, I don't know if substitution is really going to help. Come on.
So when you did that, is it like you just put 4y to the power of 4 minus 12y squared, like in brackets, and then you do the same with the other one?
Yeah, I split this up into minus 12y squared plus 1y squared. That's a minus 11y squared, right? So now I have 4 terms. There's 2, there's 2, and I can factor. Yeah. I can factor by grouping. This is what we did last day, right? Okay? So this, like I say, this is exactly what we did last day, only it's not a 2, it's a 4. Okay? We're probably going to want to do it this way. All right.
So we don't really have to worry about the whole A situation.
Well, the A situation. Okay, let's go on to this guy. You tell me when we're done the lesson if we need to worry about the A situation, okay? You don't. You can do every one of these without it. But you might want to, okay? Just give it time. First of all, sine x. It's not x squared. It's sine x squared, okay? That's what f of x is here. Not x, sine x. But this is the same as that, okay? We don't say sine x bracket squared. You need this. In Math 12, you'll be doing tons of this. We call it sine squared x. That means the same thing as this, okay? So I have 6 sine x squared minus 7 sine x plus 2. Was that the same as last day, 6x squared minus 7x plus 2? It was. And if that doesn't confuse you, then fine, you're not going to make a substitution. So I will do it that way first. A is not 1, so we're going to want to do this by decomposition, okay? What multiplies to 2 times 6, 12, and adds to negative 7? 12 and 1? No. 6 and 2? 4 and 3? Good. Okay, we got a minus sign here though, so is that going to work? Okay, multiplies to positive 12, adds to negative 7. What am I doing? I'm breaking up minus 7x into minus 4x minus 3x. But it's not x, it's sine x. Is that the same thing? Yeah. I still have 6 sine x squared, sine squared x. I still have plus 2. Why am I doing this? So I can factor it by grouping. What can I take out of the first 2? Just look at the numbers. 4 and 6, I can take out a 2. Sine x squared and sine x. Can I take out a sine x? Yeah. What do I have left? 3 sine x. Because 2 times 3 is 6. Sine x times sine x is sine squared x. Minus 2. Okay. What can I take out of these two? Well, this looks the same as what I have in the brackets, but I have a different sign there. So let's factor out a minus 1 and see what happens. Does that work? Negative 3 sine x plus 2. Yep, that's the same as this. Now, is this common in both two things? Sure. So we're going to factor that out. And what do I have left? 2 sine x minus 1. So, if you don't mind doing that, why would you make a substitution?
So they were just using the sign as just like an example, like any other letter, because it wouldn't be any different. Because I just see sine and cosine. That's why I'm asking. If you would solve
Well, don't look here yet. This is a different question, right? But do you see if that does that seem the same as what we were doing last day?
No, it seems the same. I would just ask, like, there's no different way to solve it just because it was sine instead of just the letters.
I'm going to do it now with substitution. Okay? I'm going to say A is sine x. Okay? So I'm going to have 6 a squared minus 7a plus 2.
Isn't a cosine?
What? There's no...
Still doing the same question.
I'm not doing this.
Oh.
I'm doing the same question with substitution. Okay, don't look at it. No cosines, just sines. Same question. I'm doing a substitution. Let a be sine x. If that declutters your brain, do you like factoring this more than this thing? Then you're going to want to do the substitution. Is this the same as this? Well, a is sine x. So this says 6 times sine x squared. That's the same as this. Okay? Minus 7 times sine x. That's the same as that. Plus 2. Okay? And you're going to do exactly the same thing. You're going to break this thing up into minus 4a minus 3a plus 2. Okay? If that's what's going to get you the mark, then you're going to do that. And if this is okay, then why would you make the substitution? Okay? All right? But remember, when you get down to the end, okay? Well, let's just do this. So 2a, 3a minus 2. Oh, look, 3a minus 2. Okay, factor out 3a minus 2. What do we got left? 2a minus 1. You can't leave it like that. That's not the question. You have to put this, wherever you have an a, you have to put it back. Okay, if you want to do the substitution. Do we get the same thing? Yeah, okay, we should. Okay, any other questions? Got one more. So far I've been saying, why bother do substitution? Well, here you're probably going to want to. Okay? Because this one can get really ugly in a hurry. Tannen. All right? 7 and a 3. Don't copy this down. I'm going to start this one without a substitution. Okay? You want to see how it's going to look? What multiplies to negative 21 and adds to minus 4? It's not 21 and 1. That's pretty much your only choice. Okay? So like I said, don't copy this. I don't think we're going to want to do it this way. All right? So I still have that. Okay, I want to break this down into minus 7 x minus 3, okay, plus 3 x minus 3, and I still have minus 3. Factor by grouping. What do I take out of the first two? I can take a 7 and an x minus 3. What do I have left? I have an x minus 3 and a minus a 1. We getting lots of brackets here? You like this, Reese? Reese is like, oh, cool. All right, what can I take out of here and here? I can take a 3. What do I have left? X minus 3 minus 1. Oh, look, I got the same thing in the brackets. Okay, x minus 3 minus 1. I'm going to take out, what do I have left? 7 x minus 3 plus 3. Okay, got everybody so far? Is that looking pretty like, oh, that's easy to make a mistake? Well, hey, if you're following, I'm not forcing you to do it by substitution. Now, you're just going to get a question like this, and yeah, you will get one like this, and it's going to say factor. I don't care how you do it. But maybe our life will be a little bit easier if I do a substitution.
So is that it? 5 like factors on the bottom there?
This?
Yeah.
That's factored, but it's not simplified. X minus 3 minus 1. 7x minus 21, right? Plus 3. So that's going to be x minus 4. What is 7x minus 21 plus 3? Now I'm done. Okay. Here's the problem with this one. It's pretty hard to check. Because to check this, you're going to have to go like this, right? Foil that, multiply all this out, okay? It's, all right, but let me do this way, okay? Because some of you are going, man, that's woo. I'm going to let, and you don't have to do A. What's your favorite letter, right? You want to do X? You want to do Y? Doesn't matter. 7 a squared minus 4a minus 3. Does that look a little nicer? You're probably going to want to substitute with this one, okay? When this thing's a binomial, this f of x, look at it right here, right? A f of x, when f of x is a binomial, you're probably going to want to substitute. Okay, so let's finish this one. What do I want to break this down into? Well, minus 7 minus 3. 7a squared minus 7a plus 3a minus 3. Factor by grouping. Take out 7a, a minus 1. Why am I using square brackets? Okay. What can I take out of this? 3. Everybody happy so far? Okay. What's my next step? I better have the same thing in the brackets. Do I keep saying that over and over again? Yeah. Yep, because if you don't, what are you going to do now? Well, you'd be stuck. You wouldn't be able to keep factoring, right? If you get, that's your clue. If you get something different in these two brackets, you must have done something wrong because you're stuck. You can't factor anymore. Okay? So that's just like what we did last day. But now you got to put this back. Okay? Wherever there's an A, you can't go any further here. Careful with the brackets. X minus 3, that's what A is. Right? A is x minus 3. Minus 1. Right? 7 times, what's A? X minus 3. If you don't bracket that, are you going to get the right answer? No. Okay? Plus 3. And I get the same thing, right? Now, but this is maybe a little easier. So x minus 4, 7x minus 21 plus 3, and Bob's my uncle yet again. Okay.
So how do you know what is in your substitution? Like you have the letter that equals whatever it is, right? But how do you know what that letter equals?
Well, whatever this thing is, that's what you're going to substitute because you want it to look like that. So this is like anything in life. I'm showing you how to do one, now you practice it.
So like in B, not like we're going to do the question, but I could go like A equals A plus 4.
Yeah.
That's what you mean.
Yeah. Get rid of this A plus 4. Now you want it to look like that, right? That's a lot nicer than this. As long as you don't confuse with the A and the A, maybe let it be X. Good old X, right? 9x squared plus X minus 10. Okay? Yeah. These guys, I think it's helpful. The other ones, maybe you don't need it. Okay? 1 and 2, A, B, E, F, H. I know 1 doesn't have an H, but 2 does, so, you know, figure it out. Okay, 3, 5, A and C. Then come back to 4. No. What? And perfect square trinomials aren't on the quiz either, okay? So I'm looking at the one I got from last year, and it's a good one to start. I don't see any perfect square trinomials. All right?